In this video, we're going to be talking about the central nervous system. The first main division in the central nervous system is between the spinal cord and the brainstem. The spinal cord is made up of nerves, and what happens in the spinal cord is that it really helps with reflexes. And so a reflex is a simple automatic response to a sensory stimulus. Like when the doctor hits your knee with a mallet and it kicks up. And so you really need the spinal cord for these sensory stimuli to go from the peripheral nervous system to your brain. And so the brain is the other component of the central nervous system. And we're going to be talking a lot about neural networks. And these are clusters of the brain's neurons working in groups. That's really these systems we're going to be talking about: the brainstem, limbic system, and cortex. So for the brainstem is the oldest part, and what this really does is automatic survival functions. You cannot survive if your brainstem is not working. And so there's a few components. One is the medulla. The medulla controls your heartbeat and breathing. You also need to know pons. The pons coordinates movements. It's also connected with sleep. You have the thalamus, which directs sensory messages to the cortex and sends replies to the cerebellum, which we will get to next, and the medulla. So it's really sort of the relay station between the brainstem and the higher levels of the brain. The next part is that cerebellum. The cerebellum is what processes sensory input, and it coordinates movement output and balance. And then finally, the last part is the reticular formation. The reticular formation plays a role in arousal. For example, if you have ADHD, there's a chance your reticular formation will be smaller. This also connects with attention. It's difficult for you to pay attention. Your arousal is not the way it should be because of the ADHD. So those all fall into the brainstem. The next thing to focus on is the limbic system. The limbic system is connected with emotions and drives. So all of these components are going to be connected to emotions and drives. There are three components. One is the amygdala. The amygdala is linked to emotion, particularly fear. Fear is connected with the amygdala, as well as memories of fear. Those are going to be making the amygdala light up. The hypothalamus is in this, not to be confused with the thalamus. The hypothalamus is linked to emotion and reward, and it directs maintenance activities. So things that help maintain your life, think eating, drinking, your temperature. This is where that drive component is going to come in. So you're driven to eat, you're driven to drink water, you're driven to get out of the cold or to cool yourself off. That's going to be the hypothalamus. And then finally you have the hippocampus. The hippocampus is going to be in charge of long-term memories. And so why is this in the limbic system? Well, if you think about it, a lot of long-term memories are there because they have some sort of emotional component to them. So that is why the hippocampus is still as part of this limbic system. And the final part of the brain that you need to know after the limbic system is the cortex. The cortex is really what kind of makes us different than other animals. The cortex is the ultimate control and information processing center in the brain. And the way we talk about the cortex is that we break it up into separate lobes. So the first lobe to know is the frontal lobe, and this is in charge of speaking. It also does muscle movements, planning, judgment. So we won't get into the specific divisions in this, but for example, the speaking section is Brokaw's area is the name. If this part is damaged, it's going to affect your ability to plan accordingly, to make good judgments. So for example, in my CETA class, like you guys will watch a video about a vet who had his frontal lobes damaged, and what does that do when it comes to planning out his life, making good decisions? How is it affected? Frontal lobe, very important. The next component that you need to know in the cortex is the parietal lobe. And the parietal lobe receives sensory input for touch and body position. So the thalamus is going to send some of the information to this parietal lobe on where your body is positioned, how that is working. That's all you need to know for that. You also have a temporal lobe. This temporal lobe receives information from the ears, so it receives auditory input. And then finally, you have the occipital lobe. And this receives visual input. But again, this temporal lobe is in charge of hearing. So even if you are deaf, you still use your temporal lobe. If you're watching someone sign, it's going to come in through that occipital lobe and then get transferred over to the temporal lobe for you to understand what is going on there. So those are the lobes. But a few other divisions in the cortex that are also important. One is the motor cortex. The motor cortex is not a lobe, it's called a cortex. That is going to control voluntary movements. Because remember, again, involuntary movements are going to be more of that peripheral just response with that spinal cord. Your brain is going to come into play more with the voluntary movements when you choose to move your leg versus it reflectively responding to input from the environment. You also have the somatosensory cortex, which registers and processes body touch and movement sensations. So again, this is also going to be connected to that thalamus, the somatosensory component. And then finally, the last definition to throw in your notes connected to the central nervous system is the association areas. These are areas involved in the higher mental functions like learning, remembering, thinking, speaking. All those are called association areas. So more than one area of your brain can be involved in a certain function. So for example, memories, it's more than just the hippocampus. It depends if it's short-term, long-term, whether there's an emotional component to it. Certain sites can make a memory pop up. Multiple sites can be connected in learning, whether it's like classical conditioning or operant conditioning. We'll go a little bit more into that in class, but that's what association areas are. So all of these are the definitions that should be in your notes for the central nervous system.